Hello everyone. So today let's solve the problem two parts, right? So this was asked in the Codeforces beta round 36, right? Let's see what the question states here, man. Yeah, just give me a second. 1 second here. Yeah. Now we are given M unordered edge, right? So we have been given or we are given this one M unordered edge records, nothing but the papers, where each record is an undirected edge between two different cities, where each record is an undirected edge. Just remember this one, undirected edge between two different cities, right? So these M records are exactly concatenation of these M records are exactly concatenation of two journeys, two journeys, right? So two journeys in the sense each journey can repeat edges. Just remember this, and every record must be used exactly once. Every record must be used exactly once here, right? Yeah, this is fine, I believe. So what we need to do here, we have to reconstruct not this one. We have to reconstruct two non-empty sequences of the record. We have to reconstruct, right? We have to reconstruct two non-empty sequences of the records. Two non-empty sequences of the record indices that represents the order of roads traversed in the two journeys, or we have to print -1, or we have to print -1 if it is impossible. If it is impossible. So this is the question actually. Let me read the question out loud. Just remember, just try to listen to this carefully, right? So we are given M unordered edge. M unordered edge records, nothing but the papers, where each record is an undirected edge between two different cities. Yeah, these M records, these M records are exactly the concatenation of two journeys. Are exactly the concatenation of two journeys. Each journey can repeat edges, and every record must be used exactly once. And every record must be used exactly once, right? So we have to reconstruct two non-empty sequences. We have to reconstruct two non-empty sequences of the record indices that represent the order of the roads traversed in two journeys. Traversed in two journeys, right? If it is impossible, then we have to print -1. So I hope the question part is completely clear, man. Let's do one thing. Let's move on with the this one. What do we call input output part actually? Yeah. Let's move on with the first example here. Let's consider first example. We have been given here m equals to 2, right? M equals to 2, and edges are here 4 to 5 and 4 to 3. Yeah, this can be represented in this way. This undirected graph. Yeah, so they have clearly mentioned in the question, it is an undirected graph. So we have two edges, nothing but M or N we can consider here. This one, 2 and 4 to 5. So we can just write the graph in this way, right? 4 to 5, or we can just write it 3, 4 to 5 and 4 to 3. Yeah. So this one, this is nothing but the graph representation accordingly with the input that they have given. So one thing I want to tell you here is to solve this particular problem, we will be making use of Euler tour actually. Euler tool, right? So we'll be going with a Euler tool to solve this particular problem, right? So recently we had discussed the Euler tool technique algo as well. If you remember, there are three conditions, right? One is having the odd edges when the this one vertices are even, or when this one, yeah, uh, or when the this one, what do we call that? How do I say? Just give me a second here. When we have exactly two odd vertices, and when we have when the this one when we have this one even vertices, or it is said to be this one, what do we call? So if we have even vertices, then it is said to be Euler circuit. If we have odd, exactly two odd vertices, then it is said to be Euler path, right? Else it is not this one, Euler path or circuit, right? If you remember the algo. Yeah. So the same thing, we'll be making use of the Euler 2 here. So just remember this, right? And now, as we are completely familiar with the question as well as the this one input output part here, let's do one thing. Let's quickly discuss the uh, what do we call approach followed by the complexities, and then let's write the code. As usual, let's discuss the approach first. So here I have considered the same first example that they have given in the question, right? So we have already discussed this one. The output that we need to get here is 1211, right? So we'll be making use of the Euler-Tour technique to solve this particular problem. Yeah. Now let's move on with the step-by-step explanation. See here. So we have m equals to 2. The first edge is from 4 to 5 and the second edge is from 4 to 3. Yeah. So this is correct. I have already shown this one. Let's move on with the first point, man. So we have to compute or calculate the degrees first thing. So here degree of 4, we have 2, right? So degree of 4 is 2, and degree of 5, we have only 1, right? 5 to 4 actually. Degree of this one, 3 actually, 3 to 4. 5 to 4, for a degree of 5 is 1 and degree of 3 is also 1. Yeah, this is we know. So now see here, degree of 5 is 1 and degree of 3 is 1. So this is even, this is odd, and this is also odd. Yeah, we have exactly two odd vertices. We have exactly two odd vertices, right? Yeah. If you remember the Euler, this one, what do we call Euler path or Euler path or circuit algorithm? So if you have exactly two odd vertices, then it is said to be Euler path, right? So now what we will do, we will pair the odd vertices. We will pair the odd vertices. See, pair the odd vertices is 3 and 5, right? Yeah. So for this one, we had odd this one value 1, and for this one also we had the odd value 1. So we'll pair the odd vertices and a fake edge. So we will be including the fake edge. Just remember this one. This is very important. We will pair the odd vertices and a fake edge between 3 and 5. Between 3 and 5, right? So we'll be going with a marker ID -1 for this. Now every vertex has even degree, man. Yeah. So as we are going with a fake edge between 3 and 5, 3 and 5, now every for this 3 is also having the even degree and 5 is also, yeah, having the even degree. 4 is quite obviously having the even degree too, actually. Yeah. Now 3 and 5 are also having the even degree, right? Graph decomposes into the Euler cycles. Now graph decomposes into Euler cycles. This is why. Find next, let's move on with the finding Euler tools actually. Each Euler cycle, so now we have Euler cycles, right? Accordingly with the previous point. Each Euler cycle contains the fake edge, yeah, 3 and 5 basically, these two, this one vertices. So each Euler cycle contains the fake edge. Splitting that cycle at the fake edge yields exactly two trails of real edges. Yeah, we know this one. Splitting that cycle particularly at the fake edge yields exactly two trails of real edges, right? So this is fine. Now those two trails correspond to the two journeys, right? When we split basically those two trails, this one correspond to the two journeys. For example, we get the trails for the edge 2. We will be going with a 4 3, and for the edge 1 we will be going with a 4 and 5, right? So we are having this one exactly two journeys, right? So this corresponds to the exactly two journeys, right? So we have to output the lengths as well. They have asked to this one, what do we call, go with a lens as well, right? So and we have to output the lengths 1 and 1 as well. For this length 1 and for this length 1, this is fine. And we have to output the lengths 1 and 1 and their indices, right? And their indices, right? Length will be 1 1 respectively, and we have to this one, what do we call, output the journeys as well. So this will be 2, and first one, the index, we have to, this one we have to go with a, what do we call, index as well. That is nothing but 1. So overall output that we need to display here is 1 to 1 1, right? So the output that we got here is 1 to 1 1, which is equivalent to the output that they have mentioned for the example 1 within the question, right? As we are completely familiar with the this one approach, let's move on with the complexity department. So what will be the time complexity here? The time complexity would lead to m log d. So what will be d here? So d is nothing but, here in this case, d is the degree variety due to the tree set removals. Just remember this one. Yeah, degree variety due to the tree set removals, right? So this one we can represent this one in a simpler way. We can just give m log m as well in the worst case, because each edge insertion, because of the each edge insertion and the removal in the tree set basically costs big of log m. We can just consider big of m log m as well. But it's better to go with m log d, because d is the, we are going with the degree, right? Where d is the degree variety due to the tree set removals, right? So the time complexity, overall time complexity, would lead to big of m log d. So what would be the space complexity here? The space complexity would lead to big of m plus b, because we have to store all the edges and the vertex degree information, right? Where v is nothing but the number of distinct cities, right? So the Time complexity and the space complexity for the code that we'll be writing in the future would be big of m log t and big of m log v respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So let's start writing the code. I'll just come here. Yep. First thing is we will be making use of the different input outputs. I mean fast input and output. So let's input the, so let's, what do we call? Import here, input output package basically. Just go with input output. Along with this, let's import the util package as well. I'll just go with util.start. This is fine. Yeah. Next, let's do one thing. So we will be going with a Euler class. So let's go with the class actually. Uh, Name this one Euler or you can just go with the main as well. Or I'm just going with a, that's relevant to this question basically. We are implying, or we are we will be making use of the Euler mainly for this particular problem, right? So I'll just go with the class name Euler. Now, first thing, let's go with the maximum vertex ID, man. So this is vertex ID bound actually. Yeah, problem allows vertex ID up to 10,000 accordingly in the constraint. So I'll just go with some extra as well for the safe, this one safer side. Right, so I'll just go with here static final int here. So this one I'll just consider maximum variable we are considering max v. I'll go with maximum vertex, right? So this one I'll just consider 10,010 for the safer side. Yeah, this is fine. Second. Yeah, 1,10,000. Sorry, it's 1,10,000 actually. Sorry, it was 1 lakh. I'll just consider 1,10,000 for the safer side. Accordingly with the constraints. Now let's do one thing. Let's go with the adjacency, man. Adjacency, nothing but for each vertex we have to store set of neighbor comma edge ID pairs, right? So nothing but the adjacency basically. So I'll just write it in this way. Static here, reset. So let me go with pair here. This is fine. G equals new reset of this one max n or max v actually. Yep. So this is the adjacency lists actually. This one ordered sets. Right. So now let's go with a degree array. Degree array again. I'll just go with static here. Int degree. So this one will be new int of max. This one is fine. The next one would be, let's go with the temporary path container to collect the edges during the DFS thing, but the Euler, right? So I'll just go with static here, array list. So this one will be integer. This is fine. I'll just go with path equals. So let me go with path equals new array list. Yeah, let me complete the syntax. This is fine. Next, we are done with the initialization part. Let's go with a helper pair class just to store neighbor and the edge ID, right? And also we have to enable the comparisons in the tree set, right? Let's do that as well. So now I'll just go with your static class. Let me go with pair. So we have to make use of the implements keyword here. Implements this one comparable of, let me pass pair here. This is fine. Yeah. Now let's do one thing within this class. Let's go with a neighbor vertex, also the edge ID, right? So this one will be int v, also int id, int v and int id. This is fine. Let me go with a pair now. So here, let me go with the parameters w as well as the double I. Yeah, this is also fine, man. Now within this one, so this is nothing but the constructor part, right? So let me initialize v to double v as well as id to double I. Yep. Now this is fine. Let me come out of this one entirely. Now, further steps, let me go with a int this one compare to. So let me make use of the compare to here. This is fine. So I'll just go with where. Oh, so let's write the simple if condition, man. First we have to compare by the neighbor vertex, right? So I'll just go with if v not equal to We have considered O, right? So O dot V here. Then we have to return what we need to return here. V minus O dot. In simple terms, we are first comparing by the neighbor vertex. Next, then after comparing by the neighbor vertex, then we have to compare by edge ID, right? Just to distinguish the parallel edges. So let me return here this one ID minus O dot ID. So this is fine. Yep, this is fine. Let me come out of this one entirely. Now let's go with a DFS helper method. So I'll just go with static void DFS. This is fine. Let me go with int u. Yep. So within this helper method DFS, so while there are unused edges from u, right? So suppose while there are unused edges from u, so I'll just go with while here, while not of g of u, this is fine. I'll just go with is empty. Yep, this is also fine. Then within the while loop, first thing is let's pick an arbitrary incident edge, right? So I'll just go with here where p equals g of u dot first here, right? So g of u dot first. So the next step would be let me go with the neighbor vertex as well, which is of the type int. Let me consider variable v p dot v. So now let's go with the edge ID, right? So I'll just go with the EID, nothing but the edge ID. Let me assign this one to PID. This is fine, man. The next step would be let's remove this oriented pair from use set. This is nothing but G of U dot remove of this one. What do we call? We have to remove P, right? So this is fine. Then we have to remove the opposite oriented pair from the V set. So this one will be similar. G of U uh, g of v it has to be, yeah, this is fine. G of v dot remove what we need to remove. Let me consider new pair here. This is fine. I have to pass u comma pid eid edge id, right? Sorry, this is fine. Yep. Now we haven't written, we have to perform the dfs actually. We haven't written the this one, what do we call? Mm, so basically we are performing the dfs, right? So just give me a second here. We have to recurse, I believe, right? So let's continue the Euler search from the neighbor, right? So let's recurse. So this one has to be DFS of V. Yep. Now let's do one thing. Finally, let's record the edge ID, this one, when backtracking, meaning we'll be going with a post order, right? So I'll just go with your path dot add of edge ID is nothing but EID. This is fine. Let me come out of this one entirely, man. Yeah. Now let's do one thing. Let's go with a main method. Let's move on with the main method. Let me remove this and also let me include here throws exception. Yeah. Now within this main method, the first thing is let's go with the buffered reader and the print writer. So they have asked us to make use of input.txt as well as the output.txt for this particular problem. Yeah. So let's make use of the input.txt for within this one input. So we have to read from the input.txt and we have to write to the output.txt file. That's what they have asked in the question. So let's make use of it, right? Yeah. Now I'll just go with buffered reader. Br equals new buffered reader of new. Let me go with a file reader. Yeah. File reader. This is fine. So I'll just go with input.txt. Yeah. Let me do one thing now. For writing file to output.txt, let me make use of print writer here. Nothing but output. I'll just consider out here. New print writer of new. So this one has to be buffered writer, not the reader. We are going with the output, right? So we just have to write into the write to the this one output.txt file. Buffered writer, buffered writer of. Let me go with new file writer. So this has to be instead of the file reader, we'll be going with a file writer of. Let me pass here this one output.text. So this one will be output.txt. Yeah, this is fine. So this is it. Next, let's initialize the adjacency sets for all the possible vertex IDs. So let's move on with the iteration part. So this one will be int I equals 0, I less than what we have made use of max vertex, nothing but max week. So let me increment the I here. So this one G of I, let me assign this one to new reset. So this is also fine. So the next part would be we have to read number of papers, nothing but the edges. So this one will be int m equals integer. So somewhere I have made use of small I for the integer. Did I use this one somewhere? Integer, no, right? Mm, so this one has to be capital I. That is the reason it is showing small I here. Yeah, this one m equals. So we have to. So this is nothing but then this one, this part, this one or this one, the first line. So integer dot. Let me go with. We have to parse, right? That integer. This one. Let me go with parse, and we are making use of the buffer data. Let me go with a read line here. This is fine. Let's trim the white spaces as well. Right. So because we have to trim the white spaces because we have only single integer, man. We don't need space. This one, even if double integer, triple integers are given, the integers, number of integers, it doesn't matter. We don't need any space. So we are making use of trim here. Right. So this is fine, man. Yeah. Next thing here would be let's track the maximum vertex ID. That's already seen. Right. So for that one, let me make use of max vertex here. Let me initialize this one to 0. We are just initializing here, right? So now let's read the edges and build the undirected multi-graph. So this is where the real, this one, logic part. We are moving into the real logical part, right? So this one, let's read the edges and build the this one, undirected multi-graph here. So this one will be for I equals 1, I less than or equal to m. Let me increment I. Also, within the for loop, let me go with the string builder here. Mm, variable name with a variable name st. Create instance of its string builder or sorry, string builder. Or we have to go with the string tokenizer, not the string builder. Sorry, have to, yeah. Let me go with the tokenizer, not the builder actually. So let me do one thing. I'll just go with string tokenizer here. Again, we are making use of the buffered reader. So buffered reader dot read line. This is fine. Now we have to consider city A and city B, right? So both are of the type integers within the question. You can clearly see here city A and city B. Yeah. So either you can consider this one city A and city B. This part. Yeah. This one is fine. Let me copy the same thing where this went. Actually, this line. Copy this one and let me paste this one twice here and make the necessary changes. So instead of m and n, I'll just go with the variables, different variable name. So this will be a and b. And here, instead of buffered reader, so we will be making use of the string tokenizer. String tokenizer variable, actually we considered st, right? So this one will be instead of the read line, I'll just go with the this one next token actually. Yeah. So I'll just go with next token. Yeah, this is fine, man. Let me remove trim as well. This is not needed, man. Yeah, this one is fine, I believe. So let me copy the same thing. We don't need any this thing. So let me paste it over here and let's change this one to B. This is enough. We have successfully considered city A and city B. Now the main part, we have to add the oriented pair actually from A to B comma I, B comma I, and B to A comma I. So let's add the this one oriented pairs actually. So this one will be G of A dot, let me add here new pair. So this one new pair of let me go with b comma I. This is fine, man. Yeah. Let me do the same thing vice versa. Sorry. Let me copy this one entirely and let me paste it over here. So this one has to be instead of A, let's consider B here. So here instead of B, let me consider A. Yeah, we have successfully added the oriented pairs, right? So this is fine. Now after doing that, so we have to increment the degrees. We have to increment the degrees. So we are considering A and B, right? So we have to increment the degree of A, degree of B. Next, after incrementing the degrees, we have to update maximum vertex ID. Let's do these things, these two things quickly. So this one will be degree of A. Let's increment this one, as well as degree of B. This is fine. Yep. The next part would be if A greater than max vertex. This is fine. Max vertex equals A. This is fine. Yeah. Now let's move on with a B. Let's do same thing for B as well. So instead, this one max vertex will be B actually. So here we have to change this one from A to. So this is fine. We have successfully updated the maximum vertex ID. Now let me come out of this one for loop entirely. We are done with the for loop part. Now we have to go with the trivial impossibility. When I say trivial impossibility, it must be at least two edges to split into two non-empty journeys, right? So accordingly with the approach that we had discussed. So we know this. So I can just write it in this way. If m equals 1, then let me go with out dot println. So this is fine of -1. Yeah, this is fine, I believe. This is impossible when only one paper. And next, let's go with the out dot close. This is also fine. Next, let me go with a return. Let me go with a return. Yeah. Now let me come out of this one entirely if condition. Yeah. Now let's collect all the odd degree vertices. When I say collect all odd degree vertices, I'll just go with here array list. So this one will be integer. This is fine. Integer. So this one odd equals this one new array list. New array list. So this is fine, man. Yeah, now what we will do, let's move on with the iteration part. So this will be, we have to start with 1 actually. I less than or equal to, we have to consider max vertex. Let me give I plus plus. So this is fine. So within the for loop, let's write the simple if condition here. If degree of I, this is fine, degree of I, and let me go with the bitwise and I. So sorry, bitwise and 1 actually, not I, sorry. This one degree of I actually and bitwise 1. If the value, if it is equivalent to the value 1, then let's this one add I to the odd basically. Yeah, number of odd count, right? This is fine, man. Yeah, let me come out of this one entirely. Now let's do one thing. So we have to go with a number of odd vertices that must be even, right? So that must be even. So always true for the graphs actually, but we have to check for the consistency as well, right? But we have to check for the consistency again. So we are doing the same thing over here, right? So this one, if degree of I, this one and bitwise and 1. So we are basically counting the number of odd vertices and this one equivalent to the one that itself we are doing. So now let's go with the number of odd vertices that this one number of odd vertices must be even. For that one, if you remember the approach, we added one fake edge, that -1 marked id -1 that we considered. You can just rewind the video and you can just go and see that, right? If you this one at the approach part, we created a fake edge between this one, what do we call 3 and 5 actually. Yeah, so that all the edges are even, right? So that's what we did. So that step we will be doing now basically. Yeah, now let's go with the number of odd vertices that which must be even, right? So this is always true for the graphs, but we have to check the consistency as well, right? So I'll just go with a simple if condition here. If odd dot size, mm, so bitwise and 1, this is fair. So if it is equivalent to 1, then I'll just go with out dot println. This is fine of -1. This is also fine. I'll just go with out dot close here. Yep. Next, finally, we have to terminate from there. So I'll just make use of the return. So let me come out of this one entirely, man. Now let's do one thing. We have to pair the odd vertices arbitrarily, and also we have to add the fake edge with id equals -1 for each pair, right? That we will be doing now, right? So let's do that one. Let's move on with the iteration part. So this one will be int I equals 0, I less than, let me go with odd dot size. As we are making use of Java, we have to involve parenthesis, not the JavaScript, right? I equals I plus, right? So this is fine. Now let me go with u equals odd dot get here of I. Let me pass I here. This is fine. Also, b equals odd dot get here of I plus 1. So this one has to be I plus 1. Yep. Now let's add the fake edge, man. Nothing but marker minus 1, right? So I'll just give here g of u, the node u dot add. Let's go with new pair here. This is fine. We are adding vertex minus 1, marker minus 1, right? So let me copy the same thing for the node v as well. I'll just go with here instead of u. Let me make this one, change this one to the v. Also here, instead of v, let's change this one to the u. Simple. Yeah, simple. Let me come out of this one entirely now. Let me come out of this one entirely. Now let's go with a container for the found trials. Each trial is a list of real edge IDs here. So I'll just go with the array list here. Let me make use of the array list. I'll go with the integer. So this is fine. Yep. Let me go with the trials here. So this one is new array list. So this is fine. New array list. So now let's run the Euler traversal from every vertex that still has edges. So for this, let's move on with the for loop. So this one, int I equals 1, I less than or equal to max vertex. This is fine. Let me increment the I. So within the for loop, let's go with a simple this one if condition. So we are running the Euler traversal here from every vertex that still consists of edges, right? So let's write the simple if condition. If not of the graph of I, this one, uh, when it is not empty, basically, let's make use of the is empty operation. So within the if condition, let's find the Euler circuit or the chain. We have already written the DFS. Either we can go with a DFS or you can just make use of the Hierhauser's algorithm as well. Both works, right? DFS is easy, man, comparatively to the going with another algorithm and implementing the entire algorithm. The code will be actually huge, right? So I can simply make use of the DFS for the this one to calculate the Euler path circuit, right? So I insist you to, if you know the algorithm pretty well, Hierhauser's algorithm, so you can just go with it as well. So the code will be lengthier. So I'll just go within the this one DFS. Basically, while this one explaining the algorithm, I have said Euler, this one, what do we call that? Euler path or circuit algorithm, it uses this one DFS or the this one, what do we call, Hierhauser's algorithm, right? Hierhauser's algorithm. Basically, we have made use of the DFS. So let me call DFS function here or the helper method that we have written, and let me pass I here. So we are just finding the Euler circuit or chain here, right? So this is fine. Next, we know this one, right? So just very recently we had discussed the algorithm, right? So will not be forgetting this one. This is fine. Now let's write the simple if condition here. If not of path, let me go with is empty. Path dot is empty. So this is fine. So within the if condition, let's go with a path that currently holds the edge IDs, EID, whatever we have considered, right? That holds the edge IDs in reverse order. Reverse order why? So during the approach, while we discuss the approach, right? So I said we'll be going with a post order, right? So here for the post order, we have to go in the reverse order itself, right? So here we are going with a path that currently holds the edge IDs in the reverse order, nothing but the post order. Also, we will find the segments that is separated by the fake edges. When I say fake edges, nothing but the segments that consist of the value -1. Yeah. Now let's do that. I'll just go with collections for the reverse order, or else we have to write that one custom. Mm, right. So we can just make use of the collections, right? It will reduce a lot of code actually. Collections dot reverse, this is fine, reverse of let me go with path actually, let me path here. So this is fine. Next, let me go with the array list here. This is fine. Let me pass the integer. This is also fine. Current equals, let me assign this one to the new array list. This is also fine, man. Yeah. Now let's do one thing. Let's move on with the for loop. Let's move on with the iteration part basically. So this one will be for id of path. This is fine. So let's move on with the if condition here. The fake it splits two real segments here. Nothing but if id equals -1, then suppose if not of current here, this one if it is not empty, right? So I'll just make use of the is empty operation here. When it is not empty, then I can just add here what we need to add here, new array list. Right? So let me complete the syntax also. Let me pass here current basically. We're just adding this one to the trails, right? So this is fine. Also, we have to clear after that. So I'll just go with the current dot clear, right? So this is fine, man. Yep. Else what we need to do? Else in the sense, so what if we have the consecutive fake edges that produce empty segment? Then we have to just clear, right? So I'll just go with the current dot clear here. This is fine. Next, let's we are done with this part. We have this if condition as well, right? If id if it is equal to -1, what if it is not equal to -1, right? So then else, what we need to do? We have to go with a real edge, meaning we have to append to the current segment, right? So I'll just go with current dot. What we need to add basically, we have to add id to the current segment. So this is fine, man. I'll just come out of this one entirely. Now let's write the simple if condition because we have to go with the final segment. Also, we have to reset for the next component as well. So let's write the code for that. So I'll just go with current dot is empty here. This is fine. So let me go with trials dot add. So this is fine. This will be new array list and also current. So this is fine. And let's reset for the next component, meaning I'll just go with path dot clear. Right? So this is fine. Yeah, let me come out of this one entirely now. Let's do one thing. We have to go with a special case. There is so much of code left, man, still. Yeah, so let's go with a special case. What's the special case here? So let me explain you. Just listen to this carefully. If we have exactly one trial that we have found, but it contains greater than one edges, right? So then what we can do, we can just split it into the this one, two non-empty trials, no two non-empty trials. Let's write the simple if condition for that. So I can just write it in this way. Just see here, trials dot size here. So this one, if it is equivalent to the one, and let me go with trails dot get of 0. This is fine. Uh, dot size actually. So if it is greater than one, then within this if condition, let me make use of the array list here. So this one integer, this is also fine. I'll just go with only equals trails dot get of 0. Yeah, this is fine. Let me go with a this one variable half. We are just splitting roughly in middle, right? So I'll just go with int half equals only dot size. This is fine by 2. Yeah. Now let's go with the array list. So this is fine. Let me go with integer. Yeah. So a this is equivalent to new array list. Let me go with only dot. Let me go with a sublist. So this will be sublist. Let me pass 0 comma half here. This is fine. The next step is again the same thing. Let me copy the entire thing and make the necessary changes. So let me copy this one. Let me paste it over here. So this one array list of integer, this remains same. Instead of the variable, let me change this one to b, and this new array list, this remains same. Again, this syntax remains same. And only dot sublist also remains same, right? So here instead of the 0, first let me go with a half here. along with the this one. Only is the keyword we have made use of along with the size of the only. So this is fine, I believe. So this is the only change that we need, right? So now in the next line, let's set here this one 0 comma a. Also, mm, let's add b to the trials, right? So I'll just give here. Let me pass the b here. So let me come out of this one entirely. We are done with the simple if condition. Now let's go with the final check finally. Yeah. So we must have exactly two non-empty trials that together use all the M papers, right? So for that also, let's make use of the simple if condition. So I'll just go with trails dot size here. If it is not equal to 2, if it is not equal to 2, then I'll just go with out dot println out.println of -1. Yep, meaning it is impossible to split into two non-empty journeys. Then we have to display -1. Yeah, that's what we are doing here. Now, let me make use of out.flusher. So we have made use of flush everywhere. So I'll just go with close for a change. Out.close. Then we have to terminate from there. So I'll just give here return, or we have to exit. So I'll just give return here. So let me come out of this one entirely. Now, we are almost at the end. So we have to ensure both lists are non-empty. So we have to go with this check, right? So let me write one more if condition here. So many if conditions. If trails dot get of 0 here, this is fine. Let me make use of the is empty. This is also fine. Or let me copy the same thing here, right? So this one, let me copy this one and paste it over here. If trials dot get instead of 0, let me give here 1, right? So those are the two chances actually. Yep. Now within this if condition, again we have to print out.println of -1. So nothing but the impossible to split condition, right? So now again let me write the same thing here, out.close and return. So these two I have copy pasted this one, right? So this is fine, man. Let me come out of this one entirely now. So we have to output the first trial, we have to output the second trial, right? So that's what we need to do. So the first trial, so this one will be out dot println actually, out dot println. So this one trials dot get of 0, this is fine, dot size of this one. Yep. Let me go with a for loop here. So this one will be in x of trials dot get of 0. This is fine. Let me come out of this one entirely. Out dot. So this one will be print actually. This is fine. X plus. So we have to leave the space, right? So for the space, I'll just append the space. This is fine. Let me go with a out dot println. This one. We don't have to print anything. Let me copy this one. Let me paste it over here. Let me remove -1 man. Yeah. Now, yeah, the same thing. We have to output the second trial as well. The same thing, but here instead of the 0, we have to give 1 actually. So I'll just go with 1 here in this case. So this remains same. Int x trials dot get off again. So let me change this one to the 1 here. So dot println. So same. We are appending along with the x. We are appending the space. So int dot println. This remains same. Finally, we are left with only one thing. We have to close the writer, print writer. We are making use of. So we have made use of the variable outright. So I can just go with close or the flush. I'll just go with a close for a change. So we were making use of the flush within every code, right? So let me make use of the close. We have successfully closed the writer. So this is it for the code actually. This is it for the code. Now, before checking the code with the different inputs, let me copy paste the signature starter template. So I'll just come here. 1 second. Let me paste this one. Yeah. So I'll just come to the question. Let me copy this one. Let's check the code now. We have to get the output 1211. 0 identifier expected. This one has to be pair O, I believe, bro. Pair line number 36 actually. Yeah. This one has to be O. parameter O that we have considered here. Let me run this one now. We have so many freaking errors, 4 errors actually. Yeah, so this one warning, this is fine. Let's leave this one. Error cannot find the symbol double B. Line number 32. We are assigning actually. So 1 second. We are assigning here, right? So this one, this is within the pair actually implement. So this is fine. Where is it actually? Oh yeah, this one why turned out to be W actually it has to be WB parameter. So this is fine. Yeah, we are left with 3 errors, I believe. Yep. What is the error? Error cannot find the symbol. Oh, this one I have misspelled read line here. Line number 64. Where is it? Where is it? Where is it? Yeah, read line. Now this is fine. This error will be gone as well. 2 errors. Cannot find the symbol next to open T has to be capital here for both the lines. Hmm. Yeah, for this one as well. Fine. Let me hit the run button. These 2 errors has to be gone. Hmm. Unchecked conversion. One warning. Exception in the main thread. Java.type. Oh, this one we get the error because we are writing into the this one. What do we call? Input.txt file, and we are sorry, we are writing it to the output.txt, and input we are for the input we are considering input.txt. They have strictly asked this one in the question, so we'll not get the outputs within the this one online compiler. Basically, let's do one thing. Um, Let me copy this one directly. We have cleared all the error. So let's hope this works for all the test cases, man. Yeah, this will not show the output here, right? So now I'll just come here. Mm, Let me give submit code. It's fine. What happened here? Yeah. Let me choose the problem. This is E, I believe. Problem E, the last one. Yeah. Let me paste it over here. Let me hit the submit button. I hope this works for all the test cases. Let's see. Let's wait for some time. Hope this works, man. So if you want to check the output, you can just remove the input. Sorry, wrong answer on test 15. What's the wrong answer? Let's check here. So jury found wrong answer, but participant has not actually found -1. Answer is 241223. So we have got the output. Mm, yeah. Let's see what we have done wrong actually here. So what I've done here, I have added this one actually equals as well as the hash code as it was not working. So this is one of the things I wanted to try. So I hope this works. So I'll just show it to you. So here I've just written here this one, right? Pair implements comparable. So for accordingly with this one, what was needed actually, along with the compare to, I have just added this one. What do you call? This one equals as well as the hash code. You can just pause the video and have a look into it. You can just add this one, these two things. Let's see whether this works or not first. So I'll just come here. Let me select E and let me paste the code and submit. I hope this works, man. So that was the problem, I think, I believe. I don't know. Let's see. Hmm. I hope this works, man. Long code actually. Oh, again, we are getting the same wrong answer. So here I have written the same thing in a different way, right? So I have just added this one, uh, considered another variable and assigned to this one and made somewhat this one, made some changes, right? So here this one I have added instead of writing 0 and 1. So see here I have written in this way. There are some changes that I have made. So the logics remains same actually. Let's see whether this works or not actually, at least. Just keep two paths here and let me hit the submit button here. I hope this works, man. Yeah, what happened here? I have submitted exactly the same code before. 1 second. So let me remove this. Let me submit this one again. Let's wait for some time. I hope at least this works, man. I'll just give this code actually. Mm, I got confused actually, to be frank, while writing the code. I have made several changes actually. The logic remains same, but I have made several changes actually while writing the code. I have written this one in a different way. I'll just give the code. So yeah, you can clearly see here the verdict that we got here is accepted, right? So whatever the code that we have written works absolutely correct for all the test cases. For now, this is it. Thanks for watching, guys.